So once we have all of our accelerations and velocities and initial positions in the x and y, we can plug those into our parametric equations that look like this, so that we can describe the path of the projectile coming off the table and the path of the car coming down the ramp. Okay, and what we want to do is we want to find the intersection of those two curves, because we want to know where my car is going to hit the ramp, because that's where I want both of my cars to be at the exact same time. So to do that, we set up our parametric equations, and I already set mine up over here. I just used all the values on the previous page. The only thing is this is my acceleration times time squared, but I went ahead and multiplied it by 1/2. I used acceleration due to gravity as being negative 9.81 meters per second squared. And so 1/2 of that is 4.905. Okay, so we want to find the intersection of these two curves, but we can't do that in parametric mode with our calculator. So what we need to do is we need to eliminate the parameter. So the first thing to do is solve the x equation for t, and then we're going to plug that in for t in our y equation. So I just divide both sides by my 7.95 or 0.795, and I plug this in for t over here. So now my equation becomes y is equal to 0.755 minus 4.905 times x over 0.795 squared. Remember, I'm not using units because I don't want to have a bunch of different variables, because I'm going to plug this into my calculator. I just want to have x's and y's. So the second one, we want to solve our x equation for t as well. Okay, and so to do that, I would subtract my 0.453. I would multiply this side by 2 to get rid of that 1/2, and then I would divide by this negative 1.489, and that's all going to be equal to t squared. Okay, we could take the square root to get what t is equal to, but if you look at my second equation for my parametric, the y equation, there's a t squared here. So what I can do is I can just plug this in for t squared in my y equation, and that's exactly what I'm going to do. So my y equation is going to become y is equal to 0.071 plus 1/2 times negative 0.233 times this value instead of the t squared, times 2 times x minus 0.453 all over negative 1.489. Okay, and so now I can plug those two equations into my calculator and find the intersection point. You should be able to plug these equations in as regular functions. Make sure you're in regular function mode. And then when you want to find your intersection, remember that we need to do the menu, analyze graph, intersection. It asks for a lower bound, so go to the left of the intersection that you're concerned about, click enter, go to the right because it asks for the upper bound. That means to go above the intersection, hit enter, and it will give you that value. And my value for my intersection was 0.302 and 0.047. So this gives me the x and y position that my car collides at. So if I had a picture, my car coming down the ramp, my car coming off the table, this spot where my projectile hits my ramp is the spot where x is equal to 0.302 meters and y is equal to 0.047 meters. So that tells me where my objects will collide. Okay, so now I just have to make sure that I get the time right and that they are at that point at the right time. Okay, so that's the next thing we need to calculate. The time from release until impact, and this is for the projectile. So remember, we send our projectile down a ramp so that it accelerates to a velocity, and then it goes for a little distance on the table. So what I want to know is the entire time it takes from when I release it from here to get all the way to the ramp. Okay, so we can calculate the time that it takes to get from the edge of the table to the ramp, and we can measure the amount of time that it takes for it to get from the top of the ramp to the edge of the table. I would take several measurements with a stopwatch and take the average of that. And it turns out for my car that to get from the top of the ramp to the edge of the table takes about 0.44 seconds. So now I just need to find the time that it takes to get from the edge of the table to the ramp. And to do that, we can use our parametric equation and these values here. So I want x to be equal to 0.302, and I want to know what time that occurs at. So I'm going to use this equation here, and I'm going to set it equal to 0.032. And I want to solve for the time for when that occurs. So I want to know when my car from the table is going to be at 0.302 meters. And when I solve for that, I get 0.379 seconds is what my time is equal to. But I have to remember to add back in this 0.44 seconds. So my total time, so this is just the time that it's in the air. So my total time is actually going to be the 0.379 seconds plus the 0.44 seconds. And so that gives me a total time of about 0.819 seconds. Okay, so now with this time, I know how long my car on the ramp has until it needs to get to this same position. Okay, so now what I do is I want to figure out where does my car need to start on my ramp. And so to do that, I'm going to figure out where in the x direction my car needs to start. So I want to figure out what the initial x distance needs to be so that when I release my car on the ramp down here and on the ramp up at top, that they hit at the exact same time. So I'm going to use the x is equal to the x initial plus the velocity initial in the x direction times time plus 1/2 acceleration in the x direction times time squared. And I'm going to plug in what we know. We want to solve for what my x initial needs to be. Okay, my initial velocity in the x direction on the ramp on the floor is 0 because it's starting from rest, so this term cancels out. So I'm left with plus 1/2 times the acceleration in the x direction, which should be the same as the acceleration in the x direction on the previous sheet, as long as your ramp is at the same angle. So 1/2 times negative 1.489 times my time squared. Well, I know how long it needs to go, how long it needs to travel. That's what we calculated here.